I'm John. I'm a chemistry graduate student at UCLA, and now in this video we're going to be going over some chemistry topics. Hope you find this useful, and good luck in your course.
Okay, so finally, as sort of a summary, what I'm going to do is give you a step-by-step process to solve IR spectral problems. Now, as I mentioned earlier in the video, there's going to be a separate lesson on simply solving these type of problems in conjunction with some of the other videos of NMR spectroscopy and mass spec. But this is just kind of a brief overview of what you should do to tackle these problems. So in step one, what you should do is check the region around 3,000 wave numbers. So the absorption in this region, remember, is caused by CH stretching. So the absorption is generally to the right of 3,000 wave numbers for sp3 CH stretching of alkanes, and to the left for sp2 CH stretching of alkenes and aromatic rings. So that's summarized here. So the absorption is going to be less than 3,000 wave numbers for sp3 carbons, greater than 3,000 wave numbers for sp2 carbons. Step number two, is there a strong broad band in the region of 3,500 wave numbers? If the answer is yes, then you have an OH group that's either part of an alcohol or a carboxylic acid. If there is no absorption around 1,700 wave numbers, which is caused by a carbonyl group, then the functional group is an alcohol. It's an OH group solely. If there is a strong absorption peak around 1,700 wave numbers, then the functional group may be part of a carboxyl group. Also, what you might find is that one or two peaks in the 3,500 wave number region at somewhat lower frequencies than for the hydroxyl group or the OH stretching may indicate a secondary or a primary amine, respectively. So remember, we would have one peak for a secondary amine, primary amine would have two peaks. Finally, step three. So, is there a peak, a sharp peak in the region of 1630 to 1820 wave numbers? If yes, then you definitely have a C double bond O carbonyl stretch, or this group is definitely present in the molecule. This peak will probably be the strongest peak in the spectrum. If no peak is present in this region, there is no C double bond O present. There is no carbonyl group. So the type of the carbonyl containing functional group can often be determined by looking for the presence or absence of an aldehyde CH stretch at 2720 wave numbers, or if it's a carboxyl group, an OH stretch around 3,500 wave numbers, and a CO stretch between 1,000 and 1,250 wave numbers. So this doesn't include all of the possible functional groups, but these are definitely the most common. And so finally, a note of caution on interpreting the IR spectra. So even though it's possible to obtain a great deal of valuable information about a compound from its infrared spectrum, it's often very difficult to determine its structure based solely on this information. And so other types of information should be sought. And so that includes NMR spectroscopy and mass spec. And so those are going to be separate videos that you can take a look at.